but this is going to be a whistle-stop tour. It's a 20-minute presentation, and I'm going to try and talk a little bit about container lifecycle, yeah, but more importantly about the kind of the when is your app ready to your app ready to accept work. So what's happening inside the container. So the plan for the next 20 minutes, talk about, I'll do it very, very quick. I assume most of us have an idea at this point in time of what containers are. So very, very quick kind of introduction to containers, a little bit about the life cycle of building a container and bringing you through that process. But then more importantly, getting into the kind of ideas of how you get information about what's happening inside your container. When I started using containers, I found them to be a little bit of a black box. You could very easily get them and spin them up and have a look at them, but what was really happening inside was a little bit more difficult. So I'll talk about that in the context of how you could introduce things in Docker Compose, for example, and then we'll get into Kubernetes and more kind of real world, more kind of things you might want to do in order to find out more information, find out what's happening in your infrastructure, and some of the probes and the hooks and things that Kubernetes have, which are a really nice way to get information from inside your container, inside your running container. So to kick off, what are containers? So I always think of containers as processes. They have everything you need within that in order to run your application or to run, it's got all the libraries, it's got all of the code, or it's very much self-contained. One of my colleagues described it as a jail for software yesterday. And because of that, there's no dependencies, it's not relying on anything, so it's very, very easy to deploy different environments. You can move them around very easily, runnable on any host system, etc. So portable and very, very efficient in terms of being able to very quickly stand up and run. So containers and images. Sometimes, again, when people start working with containers, there can be a little bit of confusion around the container versus the image. So again, very easy way to think about it is the image is kind of akin to the installable software package. We have container images available for our products. You can go and pull down an image for IRIS for health, etc. And that's the kind of the install package, if you will. That's what you pull down. And then when you run that, you have your container. You have your running container, your environment. Again, very, very briefly, quick word on Docker. So Docker is the platform I'll be talking about and we use for running containers. So it's really a platform that developers use to administer, develop, ship, run their applications using containers. Very, very quick to assemble. All the applications, what you need for your application and the components. And it really aids the development and the testing and the deployment of your application and the code. So images are great. So we have you can go to the various registries and pull down images for virtually any kind of software now. Very, very easily pull those images, run the container. That's great. Again, like I said, you can pull down an IRIS image and you can run that in literally minutes. But really what you want to get to then is taking those images and start adding in your own applications. So you want to copy in your own files and the necessaries. And really what you're doing is you're going to start building your own images. And to do that, Docker has a Docker file, and a Docker file is just something you define. It's a text file in which you define all the layers you need to build up your own image, which you can then run as a container. So the Docker build command allows you to do that based on a Docker file. So a Docker file is going to start at the outset. You're going to have your base image. So again, in the IRIS context, you'll pull down an IRIS base image. That'll be your first line in your Docker file. And then you'll have subsequent steps to build up all of the components you need. You may have a production you want to deploy, so you can copy in your production, etc. You can run commands, you can specify entry points and the behavior of the container when it's running. So you're starting with this kind of base image, and then you're building in all of the things you need to run your own specific image, which would be defining your own application. So when you build your own base image, then you can use the Docker run command to actually run that container. Okay. So if you look at your container and you look through the life cycle of what's going to happen with it, once you have your image, you can then create your actual container. So you can run the create command, creates your container, and when it's created, you can start it. And when you start your container, you now have your running container running in your containerized environment. You can do both those steps in a single run command. So instead, if you execute the run command within Docker, it will create and run your container for you. Once you have a running container, it should be good, it should be ready to accept work, and it can do all the things you expect from it. You can stop your container, and once it's stopped, you can remove your container, and when that will just remove it, and you can then actually delete the container itself. Once it's stopped, you can restart it, or you can choose to pause it. The main difference between pausing a container and stopping a container is that the memory is preserved when you actually pause your container. It just suspends all the processes running within the container, and then of course you can unpause it and resume processing. You can run the remove command or the RM command at different stages, so you can actually create your container, you can remove it straight away, in which case it will then be deleted. All of these states within the kind of life cycle of your container are caused by issuing a Docker container command, so the start command, the run command, the delete command, etc. So containers can have multiple different states. So when you view your container or a list of your containers, you'll see the different states of your container. In my experience, again, starting to work with containers, typically your containers will either be running or exited, depending on what your use case is. What we want to talk about a little bit, though, is just because your container is running and it has a nice status and you list out your containers and you see it's running, is that good enough? I mean, what else is happening within your container? Is the application actually running within the container, and how do you find out if that is the case or not? So we want to start delving into the container and seeing if we can figure out some more information about it. So again, very, very simply at the outset, kind of some of the first things you'll do is you can use the docker ls command to list your running containers. You can use the all flag, which will give you a list of not just running containers, but all containers defined in your infrastructure. And then you can get a list of the IDs, and then each container has its own unique ID, and you can use that ID, for example, with the container inspect command. That will give you a lot of information about your container, how it's configured, how it's defined, etc. And then another command that's very useful, again, for finding information is the docker logs command. If you think about a container, I described it as a process. Okay, so processes, you can interact with the process. So the process itself, or your container, produces streams of output data, just informational messages and errors, for example. So again, in the context of IRIS, if you're familiar with IRIS and the message log, previously the console log, information like that is written to the standard output, which can be viewed by using the docker logs command, for example. You can view it interactively, or it's actually also written to a file, so there are ways you can go and view those files within your Docker container. So these are kind of ways you can start to look and get information about your container. Again, the inspect command, you can specify flags. So if you just want, sometimes there's an awful lot of information being generated that you're viewing. So you may want to, narrow it down. And just for example, you want to check the status of your containers based on the container ID. So you can absolutely do that. And you can see in this example, it's just telling us that particular container has exited. So to delve further into it, I mentioned the Docker file. So the Docker file is a way that you can, within Docker, define your own images. So you define within the file all the steps that go towards building your own image layers. Well, within that Docker file, you can actually add in a health check. So a health check is really an instruction to tell Docker how to test something, how to test the container to see that it's actually still working. Yes, it's running, we got that. But is what's happening inside the container running, and can we ensure that we know that everything is working correctly? So the health check instruction has two forms, really. We'll talk about the first one, where you can issue a command inside the container to check the health and the status within there. Health check none is just something you can use if you want to disable any health check you may have inherited from a base image. So I described that a Docker file, you're starting off with a base image, and then you're adding all your own information. Well, if you want to disable anything you may get from the base image, you can use the health check none. So when you specify the health check in your Docker file and you run your container, it basically means you're going to get an extra status. You're going to get this health status. So when you output the information about your containers, you'll see the status. The container may be running, but there's additional information which may tell you that actually it's unhealthy, that the status inside or that the health check had failed, and it gives you further information. So there are different options around issuing a command with your health check. So for example, you can specify if you want to run a health check intermittently, you want to run it every 30 seconds, there's a duration by default, you can specify the interval. You can specify a timeout. If it's running a command and it's not returning anything, what's the timeout before it fails. You can also specify a start period. Do you want to wait a period of time after you start your container before you perform your first health check? Because container might take some time to start up, all the processes need to start, your application, etc. So, you don't want to start your health check until maybe a minute or a couple of minutes after your container has in fact started. And then how many times do you want to retry your health check before you want it to actually exit and come back and say that the container is unhealthy? So what does that look like? Well, this is a very, very simple example of a Docker file. Okay, so we're starting with a base image. In this case, it's a slimmed down version of Node.js. So that's our base image. We're copying in a file, a server.js file. It's just an example of a web server. And then we're performing our health check. So this is an example of putting that health check into your Docker file. So we specified the health check instruction. We've said we're going to issue this command every 30 seconds. The timeout is 3 seconds, and we're just issuing a HTTP request to an endpoint that you would define in your application. So this is going to run inside the application. So if you think about something maybe like if you're running a production in IRIS, you could define a service in your production which exposes this endpoint, and you're just calling into it, and you'll get some response back, determining whether or not it was successful or not, or you might get an error message, etc. So it's a very quick and easy way to issue this, to start, investigating or getting information about what's happening in your working environment. The next thing is Docker Compose. So we've so far just kind of looked at maybe a single image running, a single container, but more realistically, when you start looking at your application is probably going to involve multiple containers. Okay, you might have a container for your database, you might have a web server container, you might have a container for a front-end application, etc., etc. So, very quickly you start working with multiple containers, and that's really where Docker Compose comes in. And Docker Compose is a tool where you're able to define this kind of multi-container environment. Again, it's a file, it's a text file, it's actually a YAML file, and it's used to configure the services involved in your application. And when you do that, you spend some time creating and building your Compose file, defining all of the different containers, and then when you've got that, then it's very, very quick and easy. Single command, you can fire up your entire application, which will spin up all the containers involved as defined in your Compose file. So it works again in lots of different environments. Very easy if you want to, start building your production, staging, development, testing, etc. You can run unit tests really, really fast because you've defined everything in your Compose file. You issue the up command, you run your tests, you bring it down, job done. So it's very, very efficient for things of that nature. But again, we want to know what's happening inside the containers. Is everything working when they're spun up? So again, similar to the example I gave in the Docker file, there's a health check instruction that you can use in your Compose file. And again, it looks very, very similar. Okay, so here's your health check. It overrides anything that you may have written in your Docker file. So if you've written a health check in your Docker file and then you use Docker Compose in order to instantiate that as one of your containers, this health check will in fact override it. And you can see it takes a very, very similar form. So we've defined our health check. Again, it's issuing a HTTP request here to some endpoint you've configured in your application. And again, we've got our interval. It's got a minute 30 seconds. It's going to make this call every minute 30 seconds. Got a timeout, how many retries, etc., etc. Okay, let's talk a little bit about Kubernetes. So Kubernetes is really, again, if you're going to start looking at kind of larger applications, you really need some way in order to actually manage and orchestrate your application. And Kubernetes is really the most pervasive technology for doing that. It was developed by Google in 2014. It's vendor neutral. And the nice thing about Kubernetes really is it is backed by a very, very large community. So there's lots of information that you can get there about Kubernetes and how to configure it and define it. I can't begin to go through all of that now. So very, very quickly, Kubernetes really, what it does for you in the containerized world is it allows you to configure at scale, your environment and have your applications operate exactly as you've described them. So things like service discovery, load balancing, storage and orchestration, self-healing, which is important. We'll talk about that. What happens if one of your containers does become unhealthy or goes down? What does Kubernetes, or what can you do about it? And again, things like self-healing, and configuration, APIs across it, etc. It's a really nice environment for building out a large-scale deployment. This is kind of a graphic of what it looks like. So within your Kubernetes environment, you've got your master node, which controls the environment, and then really you've got all these worker nodes, which are very, very easy to scale up and down. Within the worker nodes themselves, you have these pods with the containers in them. So we have our worker node. The kubelet actually controls from a Kubernetes perspective, what's happening in the worker node. But we define these pods and these containers within the worker nodes. So here's our environment. We've got 3 worker nodes. We've got multiple pods with containers running in those pods. And then what happens when a container goes down? Okay. Well, what happens is, great, Kubernetes automatically restarts the pod if it's in an unhealthy state. Sounds wonderful. So we're good to go. It'll take care of all of it for us. But the problem is that, again, similar to as I described earlier with the containers look like they're running from the outside, but inside the container there could be a bug, there could be a deadlock, timeouts, connection errors, et cetera, et cetera. So there's lots of things that can happen with inside your container, but to Kubernetes it looks like it's all fine. So in these cases, and many cases like a Kubernetes won't automatically restart the pod because it really only checks the kind of, if you look at a container, there's a main process, the first process, but within that there's a whole tree of sub-processes running, and it certainly does not go through all those. It only checks the main process to see, is it running? So we need to do something more. We need to do more to actually determine if the container is in fact healthy and if or unhealthy, and we need to do something about it. So the way we do that is Kubernetes probes, okay? So Kubernetes probes are ways that you can investigate if the pods are actually working correctly or not. And there's 3 main probes that we can look at using. So there's the liveness probe, which indicates if the container itself is operating. So we'll configure one of those. That's great. And if everything is good and the probe is reporting back that the container is running fine, no action is taken. If there's a problem, Kubernetes will automatically then restart that container. The readiness probe is there to indicate if the application is running. So in this case, it determines whether the services matching the application are allowed to actually receive traffic. So should we be sending traffic? So again, if you think about your production, should we be sending messages to this or not? Is it actually up and live and running? So the readiness probe does that. It doesn't restart the probe, but actually what it does is it just takes it out of the service, removes the endpoint essentially, and until such time as it's fixed, and it can resume traffic to that particular container. And the last type of probe is the startup probe, and this actually runs first. So when your container starts, the startup probe runs, and it indicates whether or not the application actually is running properly on startup. And the liveness probe and the readiness probe will not start until the actual startup probe has successfully returned and said, yeah, it's good, the application is up and running. So again, what do these actually look like? So the way we do this is, again, similar to the health check we saw earlier. We define a configuration file, and in that configuration file, we add in our liveness probe, for example, and it can take different forms. Okay, so this is an example of looking at the liveness probe. We're using the execute command form of the probe, where we can specify the command and what it wants to execute. So this is just going to copy or run a file. And again, similar to the health check, we can specify, again, if we want an initial delay before we start the probe, give time for the actual application to start up and run. We want to issue how often do we want to run, what's our timeouts, what's the success threshold, et cetera, et cetera. So in this case, to perform the probe, it executes the command, checks whatever command you specify in the container. If it returns 0, everything is good. Container is alive. It returns some non-zero value. Then the kubelet automatically kills the container and restarts it. And then we have our delay in seconds, you know, the various parameters you can set defining how you want it to behave. So the liveness probe, as I mentioned, has a number of different forms. That was the command. You can also run it as a HTTP request. So again, in the configuration file in this instance, it will send a HTTP GET to your container. And again, you can configure, you know, this time instead of it returning a kind of a 0, it'll return, you know, I think 1 to 200 typically. You'll define various messages it will return depending on what you want or how you want to handle the actual response. So there'll be some failure code, and you can then configure that the kubelet gets restarted automatically. And similar to the command, there's again all the associated parameters. If you want to delay the start of the probe and how often you want it to execute and what the interval is, etc. The readiness probe. So this is the probe that actually is used to determine if the container and the application running in the container can handle traffic. Okay. So unlike the liveness probe, if this fails, the pod is not restarted. It just removes the endpoint list from the services and no traffic can be sent to the pod. So once it's repaired, once it's whatever the problem was is taken care of, the probe will succeed and it will automatically add the services back in, so all the endpoints will become available again. Okay? So this readiness probe will run throughout the life cycle of your container, maintaining and, you know, ensuring that your container is able to accept the traffic and perform the work it needs to. Startup probe I mentioned as well, so similarly can take different forms. Here's an example of using the HTTP version. So again, the kubelet starts up. This only gets run after startup, and it disables the liveness and readiness checks until this actually succeeds. So the other two probes will not start until the startup probe is successful. And again, it checks to see that the application started and is running successfully. Again, to implement them, you define them in a configuration file. So, for example, we've defined a YAML file again that with, you know, outlining the probes and configuring them. And then you use the kubectl apply command. And if you issue that command, it will actually run the probes. And then in order to check and see what's happening with your environment and if the probes, if there's success or not, we can use the get pods command for, we can use the get pods command, for example. And if we do that, we'll see the status of our running pods in our architecture. So you can see here we've got three nodes running, but you can see that in the status here in the ready, we have a 0 at the third node, which indicates basically that the liveness probe failed. So if you do get a failure like that, in order to check it, you use the describe command, the kubelet describe command, specify the pod, and that will output all the information, a lot of information about the actual running node or the running container. It'll actually give you all the input and tell you what's happened with regards to the liveness probe and why it failed, etc. The last thing then I just want to quickly mention from a Kubernetes perspective is there's also these lifecycle hooks you can make use of. So we see this in many instances in software where, you know, it's like you can use a post-start and a pre-stop hook in order to execute commands if you want. So for example, the pre-stop is really nice if you want to gracefully bring down your container. Sometimes if you just stop your container, it can be a little bit abrupt and it doesn't stop nicely. So you can do things like issue pre-stop, which will, you know, shut it down more gracefully. And then the post-start is, you know, again, once your container starts, what do you want to issue against that container? What commands do you want to run? So again, you define them in a config file. So here's an example. You know, you define them under the Lifecycle directive in a manifest file, for example. And again, you're familiar with this now. You can see we can specify, again, it can take different formats. Here we're executing a command, which is just going to, on startup, it's actually just going to issue a command to write to a file on startup. Everything's okay, we're all good. And again, just anything you want to do post-start and pre-stop of your container, these hooks are kind of nice placeholders to be able to do that. Okay, again, once you define them in the file, you just simply use the kubectl apply command, and it will actually issue that command to deploy that in your containers. So to wrap up, when you're starting to look at maybe using these probes and health checks to investigate what's happening inside your container, you do need to understand the application's architecture, any dependencies, such to make them useful and to implement a really nice environment that will give you the information you need in order to determine that everything is working as expected. So knowing your application, definitely crucial in terms of configuring. I mentioned the readiness probe. That's really good. That runs throughout the life cycle of your container, so you get constant feedback, checking everything is okay from your implementation. But there is also a word of a warning as well, because conceptually they're very simple, right? We can just issue a command, we can issue a HTTP GET, whatever that is, or issue a command on the side. But it's very easy to do things that don't work. So again, it's kind of something you start off very simple, test all the way, make sure you're getting the behavior that you want. Because if you do implement them badly, they can really, you can actually make the application virtually unusable. So again, something you need to use with care, and but if you do, you can really, they're very, very valuable in terms of opening up that kind of black box, if you will, inside the container and being able to find out what's happening and make sure it's running as you want. I mentioned Kubernetes, how pervasive. So all these, they're really well documented. There's tons of examples, etc. So definitely something to take a look at if you haven't already, and maybe think about introducing into your containerized world. Thank you very much. 20 minutes to run through container lifecycle is tough. Yeah. I don't think it's actually defined as a hook. It's designed specifically around our use case for IRIS, so it's different to a hook, but yeah, it's like it's something we've just defined that you can configure as part of your file to handle the mechanism around IRIS, but I wouldn't describe it as a hook in that sense. No. Do you want to add to that? Actually, you said you were here yesterday, so Eric I see him sitting in the back, if he wants to. Okay.
He wants to hear
Yeah, we got the mic now. Sorry, the question here at the front was, is IRIS main a hook?
IRIS main is not a hook, because we need to provide a similar kind of functionality wherever you happen to be using the container. So you could certainly do a hook if you're running Kubernetes, but what happens when you're not using Kubernetes, right? Docker has the same kind of limitation. All it knows is, I'm going to kill this container. It has no knowledge of, what do I have to do to IRIS to make sure it goes down cleanly? So we put that functionality to catch a signal and handle the shutdown in IRIS main. The other reason we need IRIS main is we need that master process to stay running so that the container will stay running. That's why you can go into your container using like a Docker exec, and you can still do an IRIS stop or IRIS start, or maybe IRIS force if you need to, right? Because you're in some kind of a strange state. And you're not going to disrupt the operation of the container. The container is going to stay around until you're ready to stop it. So it's like you keep the container running, so you keep the environment that IRIS is in running while maybe you're doing some maintenance or investigating some issue or checking something. So that's why there's a difference.
I was just wondering if there's a standard health check for an IRIS image.
Not that I'm aware of, no. No. I don't know, Eric, if you know if we do. I don't think we do. There's no... There is I don't know whether it was in the community or in the documentation that I did see how to define maybe endpoints as a business service in a production in order to be able to interact with probes and health checks, etc. But I don't think there's a health check example particularly specifically around for Docker or Docker Compose.
There is a script that works with like the web gateway for checking things like which IRIS instance is my mirror primary, so I can switch over. And I have seen that used as a kind of health check, but there isn't like a standard health check that ships with IRIS.
I would like to know if you would advise to use liveness probes, because they are heavily discussed in the Kubernetes community, because they can be kind of harmful, like cascading failures. Do you have any experience on that? Because this IRIS main, from my point of view, is something like a good option to check for liveness. Mm-hmm. It should recognize there is a failure in the system and should end the process. And ending the process is the best option to see it's not live, so Kubernetes can restart. Yeah, but because normally we run kind of large Kubernetes installations and clusters, and liveness probes are more harmful than helpful. And readiness probes are good, but some people implement liveness probes like with dependencies to external systems, for example, like a database or some other system it depends on, or a web service, whatever it consumes. And this led to a lot of cascading failures in operations, in production systems. So my question is, would you advise it? Because it sounded a bit like advice to use them, but I would not advise using liveness probes.
The short answer is yes, but with caution. So that was kind of my point at the end is, yes, use them, but know how to use them. Know your application, because, like you said, they can be harmful if used incorrectly. But yes, the answer is yes. Definitely would recommend using them. But
there's also, I think, an issue at the Kubernetes community that they say in the documentation it needs to be stated directly to say, please be cautious about using it. Yeah, because Kubernetes will do a lot of automatic stuff if some probe fails.
Yeah. I mean, if you want to talk more about it, I'd recommend talking to Bob, actually. He's our manager for it. So if you see him around, he's the guy to talk. But yeah, I think in general, yes, we would. We definitely recommend them, but with caution. Thank you.